Assalamualaikum warahmatullahi wabarakatuh and hello everyone. In this video, we're going to discuss week 5 hour 3 tutorial for both non-face-to-face and face-to-face questions, which will cover for the last subtopic in electrochemistry called electrolytic cell. As for non-face-to-face questions, we have two learning objectives. The first one is to write the half-cell equations of electrolysis. Secondly, to predict the product of electrolysis. Question 1 asks you to write the half-cell equations and determine the products formed at each electrode in the electrolysis. 1a, we were given dilute aqueous solutions of sodium iodide. When dealing with aqueous solutions, you should know these two terms. One is dilute, another one is concentrated. These two terms should be addressed only when you are dealing with chlorine species. If you look at our solutions here, we got only sodium and also iodine. It means that we got no Cl species in these solutions. So we can simply ignore the dilute and also concentrated solutions. So we still need to look at the inert value to determine which species will be discharged at each electrode. So we're going to do the questions that have chlorine species in face-to-face questions. So now let's do this together. To predict the products formed at each electrode, we need to first list all the possible ions present in this solution. As for sodium iodide, we're going to have Na+, I- and also H2O. So for H2O, we're going to have two different values. One will release O2, another one will release H2. So we are going to see which of these two values will be attracted to anode or cathode. Okay, as for anode, we know that anode going to be the positive terminal. So positive terminal will attract negative ions, which in this case an ion. We know already anode will attract an ion. So the possible ions that will be discharged at the anode could be iodine and also water. So how do we know that water that releases O2 will be the one that gonna be one of the ions to be discharged at the anode? So look at the positive terminal of this anode. So they will favor water with inert value that is more positive down here. So we're gonna use this value which have O2 in its half-cell equations. As for cathode, cathode is the negative terminal. They will attract cation. So we have two possible ions here which are sodium and also water. So another value of electric potential of water here gonna be the negative 0.83. Why we take this negative 0.83? It is suggested by this negative terminal which favor a more negative value for water, and we could see that they're gonna release H2 gas. Alright, so even though they have a number of possible ions to be discharged, for each electrolysis, only one species will be discharged. So how do we determine this? By looking at the inert value. We know anode will undergo oxidations, while cathode will undergo reductions. Since oxidations is favored at the anode, means the inert value that will be favored is the more negative value. So between positive 0.53 and positive 1.23, which of those will be the one that will be discharged at anode? Okay, so we could see that this iodide ion is more negative, means they will be discharged at the anode. While for cathode, cathode undergo reductions, means they will favor more positive value of E not to be discharged. Between negative 0.83 and also negative 2.71 volt, we have negative 0.83 volt is more positive than the other one. So water will be discharged at the cathode. Lastly, we need to combine these two half-cell equations according to the oxidations and reductions process. Then we're going to sum this all together by cancelling the number of electrons here. Lastly, we're going to get the overall equations that consist of 2I- aqueous states plus 2H2O liquid states to give I2 in solid states plus 2OH minus in aqueous state and hydrogen gas. So you need to mention the products forms by having the species to be mentioned. So products formed at anode gonna be iodine solid, while products formed at the cathode gonna be hydrogen gas, as suggested from these half-cell equations. For question B, we are given aqueous solutions of copper to nitrate using platinum electrode. So let's first list all the possible cation and anions for this solution. So we're going to have nitrate ion, copper 2 plus ion, and also water. So as the same as in previous questions, we're going to have two values of water. Let's start with anode with positive terminal. We're going to attract an ion of nitrate and also water. But since nitrate is very high in its oxidation state, therefore they cannot be oxidized, and we are going to take this water automatically. And for cathode with negative terminal, we're going to attract cation of copper and also water. Cathode will always undergo reductions, therefore they will favor a more positive values. So if we compare between copper and also water, copper is expected to be discharged at the cathode. So if we combine these two, we're going to have it like this. And in order to cancel out the electron, we need to first times the whole equations of Cu2 plus to become Cu with 2 so that we can cancel these electrons out. And lastly, our overall equations will be like this. So in order for you to write the products formed, then you need to look at the anode. So at the anode, we're going to have O2. At the cathode, we're going to have copper solid. So simply write it as anode going to have oxygen gas, while cathode going to have copper solid. As for face-to-face learning objective, you need to know how to predict the electrolysis of the following electrolytes using inert electrodes. By using inert electrode, determine the gaseous product formed at the anode and the cathode in the electrolysis. For 1A, we have molten BaI2. So molten states here means these reactions require a very high temperature and pressure to melt these species. So instead of having aqueous state, we're going to have only liquid states. Please note that molten state got no water molecules present. So we are not going to involve water molecules to be part of our selections when choosing which of the ions will be discharged. So as anode will attract an ion, so they're going to attract iodide ion, while cathode will attract cation. They're going to attract barium 2 plus ion. So please note here we have only liquid states. Right, so since we got no other options to be selected, we're gonna take this anode and write it according to oxidations as 2I minus in liquid states to give I2 solid state plus 2 electron, while the cathode undergo reductions, keep the previous half-cell equations and write it again. So then you're gonna have 2 electrons on both half-cell equations. Simply cancel out this electron and you will get the overall equations of 2I minus liquid plus Ba2 plus liquid to give you I2 solid and also Ba solid. And then you need to mention products formed by looking at the half-cell equations. As for anode, we're gonna have iodine solid, and as for cathode, we're gonna have barium solid. B. Water is given means possible cations and anions that will be attracted to respective electrodes are water. Even though we only have water, but please be reminded that water got 2 SRP values, so we need to look at that carefully. As for anode with positive terminal, they will attract water that has a more positive value of positive 1.23. As for cathode with negative value, we're gonna attract the water with more negative value, negative 0.83. And then For the products formed, we need to rearrange them according to the oxidations and reductions process like this. Since the number of electrons is not daily, then we need to modify a bit for the water molecules attracted at the cathode. We have 4 electrons at the anode, means we still need another 2 electrons to be added to the cathode. So we need to modify it to become 4H2O plus 4 electron to give 4OH minus plus 2H2 gas. So if we arrange this and make it into overall equations, we're going to get 2H2O in liquid states to form 2H2 gas and oxygen gas. And lastly, products formed at anode is oxidation gas, while cathode is hydrogen gas. C. Dilute sodium chloride solutions. As mentioned earlier in the non-face-to-face questions, we need to address a solution whether they are dilute or concentrated if and only they have chlorine species present in the solutions, just like in our questions now. So to predict what kind of products will be formed at the anode and also the cathode, we need to first list all the possible cation and also anions present. We know that anode will attract an ion, so our anion in this case gonna be Cl- and also H2O. As for cathode, we have negative terminal that will attract cation, so our case we have sodium and also water. Okay, so anode will undergo oxidations while cathode will undergo reductions. Anode will discharge ions with inert value that is more negative since they are going to release electron according to oxidations reactions. So between positive 1.23 and also positive 1.36, we're going to discharge water because the value is more negative. While for cathode, they will undergo reductions and they will favor a more positive value of inert. So between negative 0.83 and also negative 2.71, we're going to discharge the value of water, which is more positive. And lastly, we need to combine these two selections as part of oxidations and reductions reactions like this and make sure that the number of electrons is daily with one another. If we look at the cathode, we got only 2 electrons, while anode we got 4 electrons. We need to first modify the one in cathode to become 4H2O plus 4 electron to give 4OH minus plus 2H2 gas. As you can see on the left hand side, we have the same species of water. If we have species on the same side, we need to first add them. So we're going to have 6 water altogether. While on the right hand side, we have a combination of 4OH minus and 4H plus. These two will combine to form 4H2O. So since we have water on both sides, we are going to cancel them out. So 6 minus 4 gonna be 2. And lastly, our overall reaction is gonna consist of 2 water molecules on the left hand side to give 2H2 gas and also O2 gas. To answer these questions, which ask you to predict the product's forms, you need to mention the species, not just the half-cell equations. So the products formed at the anode will be oxygen gas, as you can see from these half-cell equations, while product formed at the cathode will be hydrogen gas, as you can see from these half-cell equations. Now for D, we have exactly the same solutions, but this time around, the concentrations has changed. So we are going to deal with these concentrated NaCl solutions. So basically, our possible cations and also anions will be the same as in previous questions. So let's just list all of them together. So for anode, they will attract an ion. We have Cl and also water. And for cathode, we're going to have sodium and also water. As for concentrated species, the one that will be discharged at the anode should be the one that has high concentrations, which in this case, chlorine. So instead of taking a more negative value, for concentrated solutions, we need to take the one that has high concentrations, which is chlorine. And as for cathode, we should take the one that is more positive value. So we simply stick to the water molecules. So we're going to combine these two half-cell equations according to oxidations and also reductions. So we're going to get the overall equations of 2Cl minus aqueous plus 2H2O liquid to give Cl2 gas plus 2OH minus aqueous plus H2 gas. We need to cancel this electron, then only we can get the overall equations. And as for the products formed, they will be a bit different from the diluted solutions, as we are going to take anions that comes from the high concentrations solutions. So lastly, our products formed at the anode gonna be the chlorine gas as suggested by these half-cell equations, while cathode will form hydrogen gas as suggested by these half-cell equations. We'll proceed with sodium sulfate solutions aqueous. So we know that we have a combinations of sodium ion, sulfate ion, and also water molecules. So we'll sort them accordingly in terms of anode and cathode. So anode with positive terminal will attract an ion of sulfate and also water. And then for cathode with negative terminal, they will attract cation of sodium and also water. So sulfate has the same case as nitrate ion where they got high oxidation states, so they cannot be oxidized. So we're going to take water to be discharged at the anode. As for cathode with negative terminal, they will undergo reductions and they will favor a more positive value of water. So lastly, we're going to combine these two and then modify them to become daily with one another. So 4 electrons will be transferred. And lastly, the overall equations will be like this. So we could say that products formed at the anode is the oxygens, while the cathode is the hydrogen gas. Placing in electrodes with active electrodes of copper, determine the products formed at the anode and the cathode in the electrolysis of copper to nitrates. So from the solutions, we have a combinations of copper 2+, nitrate, and also water. Since we use active electrodes, means we need to include the ions of the copper to be part of the anode and also the cathodes. So for anode that attracts anions, we're going to have a possible anions of nitrate, copper 2+ comes from the electrodes, and also water. But nitrate has a very high oxidation state, so they cannot be oxidized, so means they are going to be disqualified. We'll proceed with only Cu and also water. So anode undergo oxidations will favor a more negative inert value, so Cu2+ will be selected. And then as for cathode, we have a possible cation of Cu2+ and also water. And since cathode will undergo reductions, it will favor for a more positive value. So between positive 0.34 and also negative 0.83. So copper will be selected. So both anode and cathode will discharge copper. So lastly, we need to combine oxidations and reductions process to get the overall equations of Cu solid plus Cu2+ to give you Cu2+ and Cu solid by eliminating the electrons. And products form, you can write it as anode copper 2+ ion, because if you look here, we have copper 2+, while for cathode, we have copper solid. Thank you for listening. That's all for today's tutorial. We'll proceed with Faraday's law of electrolysis on next hour. Goodbye.